what we heard across the board was everyone was slowing down in electrification. That's why we said, okay, the best thing for us to do right now is take this technology, which was working. This put the company in a position where we now have the cash we need to go execute, and we're still going after a extremely sizable market.
This is Energy Cast, and I'm Jay Downhauer. Today we're talking about how one company's transition away from their core business allowed them a chance to focus on a core technology. My guest today set out to build electric semi-trucks, big rigs, the biggest EVs you can drive. The only problem was the industry just wasn't ready for it. As my guest explains, these companies wanted to test the trucks before putting in a huge order. That's understandable for a company that wants to be careful when adopting new technologies. It's counterproductive for a startup who needs to get up their volumes. My guest admits it was painful, but what they focused on instead was their power plant for these trucks.
There were RNG and hydrogen-fueled versions of their electrified semi-trucks, but what they were really pushing was a fuel-agnostic EV with its own power plant on board.
The difference is that this generator doesn't use internal combustion.
Rather, it uses what's known as flameless oxidation, which reacts fuel and air to create heat.
As the name implies, the process doesn't even emit light. The generator spends more time with fuel than a combustion engine, which leads to greater efficiency. And instead of the fuel pushing a piston directly, this generator uses the heat from the fuel to heat a working gas, which expands and operates the piston. My guest says this is key. Since the fuel is only used to make heat, you could theoretically run the generator on any fuel. And they've identified over 20 fuel types, ranging from hydrogen to diesel fuel. My guest still believes their trucks could reach highways once again, and their power pivot was key to ensuring that that option remains for them in the future. My guest today is Thomas Hyliion, founder and CEO of Hyliion, a generator manufacturer based in the Austin area. The technology I described earlier is their Carno generator, with a K, which they acquired from GE in 2022. As Thomas explains, they're focusing on 4 sectors for this application and the gamut of fuels it can use to run it. I first approached Hyliion for a panel I was hosting last year on electric vehicles. We held the panel, I was preparing it for a podcast episode, and then had to kill the episode because Hyliion was in the middle of their difficult restructuring away from their trucks. Luckily, Thomas agreed to share his experiences from that, and I appreciated his candor and willingness to share what they learned from an episode that was probably not fun to endure.
Still, it shows how a company can stay true to their original mission and even achieve more in the process.
I hope you enjoy my conversation with Thomas Hyliion.
We're here with Thomas Hyliion, founder and CEO of Hyliion. And Thomas, your main product, Carno, what is it and how do you explain it to friends at dinner?
Well, Jay, thanks for having me on. The Carno generator, it's a unique and innovative generator solution. End all be all, it produces electricity, but it brings forward a ton of benefits. I almost like to refer to it as it's like a mini power plant. So it's not like your conventional generator that normally goes outside your home and is just there for emergency backup power. This solution's designed to be your primary provider of electricity at a facility, at a warehouse, out in the oil and gas sites, biogas, things like that. So we'll dive into a bunch more details, but think of it as a mini power plant.
Yeah, the idea behind this is it's fuel agnostic, right? And why do you think there haven't been more attempts at something like this? That seems like a pretty simple idea, right?
But yeah, it's a fuel agnostic genset, over 20 fuels that we anticipate it being able to be run on. The main ones that I think a lot of people are focusing on, natural gas, hydrogen, propane, the biogases, and even liquid fuels like diesel, gasoline, it can even run on those. In terms of why haven't fuel agnostic gensets been done before, the reason is it's really tough. And if you think about normal gensets, the number one solution out there for a generator is a reciprocating engine, whether it be a diesel engine, a natural gas, gasoline, propane as well. And the way that those solutions work is you actually bring the fuel into the cylinders, you explode that fuel, and that's what moves the piston and then produces that rotating force. What's very unique about the Carno is we don't do any of that. The fuel is purely there to be used to produce heat. So the actual fuel source for our generator is heat, and then we just happen to get that heat from these conventional fuels like natural gas, hydrogen. And so the way ours works is you bring that fuel in, you do a process called flameless oxidation. So you're reacting the fuel, but it's happening in a way where it doesn't even emit light. So you can't even see the flame. It's this extremely clean process. And the only goal of that to power our genset is we make heat out of it. And so that's where we have this unique ability to run on all these various fuels, because all of them can produce heat, versus if you think about an internal combustion engine, it's really difficult to try to switch from one fuel source to another.
Thomas, the history with Carno, you acquired the base technology, I believe, from GE.
That is correct. It was within GE's aerospace division.
And they didn't want it? How'd that happen?
It's a fascinating story. As I mentioned, it was invented out of GE Aerospace. And when we went public back in 2020, shortly thereafter, GE actually approached us and said, hey, we've got this really innovative generator solution. Would Hyliion be interested in working with us on it? Now, at that time, Hyliion was focused on building an electric range extender semi-trucks. So tons of momentum at that time around electric vehicles, specifically in trucking. And what our unique niche was, we were developing the powertrain, but our thought was, you don't want to plug these vehicles in and use the grid to recharge the truck. Why don't we actually just bring a generator on board? And so we were actually making a natural gas range extender vehicle. GE approached us and said, hey, we've got this generator. What if we use this unique fuel agnostic, more efficient solution in a semi-truck to power your batteries? And we loved the idea. It was already on our roadmap to do something like this. So we teamed up with GE and started the development. And then as we were going through it, we saw there was just so much opportunity and potential with the generator solution that we actually approached GE about acquiring that technology. And timing was fortuitous. At that point, GE was actually announcing divestiture, and they were breaking the business into 3 different sub-businesses. And so the timing was right. We made the acquisition. And as time will prove out here, we actually did a pretty significant pivot of our company where we actually announced we were pushing pause on the powertrain development and focusing our efforts on the Carno just because of the major shifts that have happened in the EV space. But as you kind of led into this call with, the Carno generator is now our focus.
I want to get to that pivot in a bit because I think that's important with the lessons learned and everything. But it appears that you're using Carno right now. I guess there could be unlimited use cases for this, but I believe the use case that Hyliion seems to be focused around right now is EV charging, maybe like fleet charging.
So EV charging is definitely one of them. There's really 4 buckets. It's EV charging. It's using waste gas. It's going after prime power, and then mobility. So I'll cover each one in a little bit more detail here. As you mentioned, EV charging, this is really due to, there's just a power deficit, right? If you're trying to deploy EV vehicles, you go out to your utility and you're being told it's like a 3-year wait time till you can even get a grid interconnect. So that doesn't work for fleets, right? They need to move faster than that. That's where we could bring a Carno generator in and start producing electricity as opposed to needing to be waiting for the grid. Then you go look at waste gas applications. Within this bucket, there's using like methane coming off of landfills, there's using biogas, there's using oil and gas sites where you would normally have to flare that gas. And since we have that unique fuel agnostic ability in the Carno generator, now we can actually take what would have been waste gas, run it through the genset, and produce a byproduct of electricity for these operations. So that's a huge win, also a big differentiator for the genset being able to run on those types of gas. Then the standard bucket, which most people think of gensets, is that prime power, which is going into commercial buildings, industrial applications, data centers, where we could come in, deploy these gensets, and the whole goal there is actually producing electricity cheaper than what you could source it from the grid. And we're seeing that we're going to be able to do that in most instances where the cost of operation is pretty low for the Carno generator. And then if you're able to source a low-cost fuel, then that makes it more economical than even grid electricity. And then the 4th bucket, which would be that EV bucket, the mobility side of things, the first one we're actually looking at going after is the marine application. So actually putting this in a boat, in a vessel, and using it as the power source to power the ship.
Yeah, that's interesting. I can see where that works well for like a ship because it's mobile and everything. Any land-based EV charging?
Yeah, absolutely. So EV charging is going to all be land-based. I think there's 2 buckets within it. One is a stationary deployment, and then the other is a mobile deployment. So stationary being, think about you go to a grocery store, they got EV chargers out front. Well, there's a lot of places that just don't have the available power needed in order to run those EV chargers, and so then they can't deploy them. We can come in and solve that. Or the other one is you actually put this thing on a trailer and put an EV charging pedestal on the trailer as well, and now you can actually move around this charger. So, think about like a warehouse where they've got rows and rows of vehicles lined up that need to be recharged. There's applications that are actually doing this today where they have these EV charging trailers. They just pull them from one vehicle to the next. They charge up a few vehicles at a time, and then by morning, they've had them all charged. But the nice thing is you actually avoid setting up all of that hard infrastructure that's kind of built into the ground. Now you just have a mobile trailer.
Yeah. My dad was a big fan of trains, so my head's kind of going towards that, because that's what a train is, right? It's like a generator on board the... Yeah.
So locomotives are range extended electric vehicles, right? Effectively, where I guess the technical term is they're series hybrid vehicles, which means you have that generator producing electricity, and then the actual wheels on the locomotive are powered through an electric motor. So locomotives would definitely be a solution that could fit into that mobility bucket for us. And, locomotives, there's a big push right now to try to move to alternative fuels, right? Diesel is the primary fuel used today. Obviously, people want to move away from that. Tons of discussion around going to hydrogen, going to plug-in electric. Fuel cells have been experimented with, so I think Carno could play well there. And then also open up other fuel opportunities, like there's the option of like even ammonia as a potential fuel to power trains, or natural gas, which, obviously Carno could be a one-stop shop for those various fuels.
Yeah, you touched on all these different applications. I wanted to talk about two of them that I thought were interesting based on your announcements you've made on your website. You announced a partnership with Biotech, who produces hydrogen. How would your products work together with that?
This is an announcement we just came out with recently, and partnering up to work together where the Carno generator would be able to use the fuel that's being produced by the Biotech production hubs. A little bit of background. So they actually build the facilities that are making hydrogen. They also are in the transport of hydrogen space. That's obviously one of the fuel sources we can use in the Carno generator. What we found as we established this partnership was we look at our customer base. Some people want to run their Carno generators on hydrogen. Well, if they're going to do that, they need to figure out what their source of hydrogen is. Biotech can provide that. What Biotech was seeing is they have people that want this hydrogen, but then some of them actually want to make an end product of electricity with that hydrogen, and that's where a Carno genset can come in. So we saw this as an opportunity that we can refer our customers back and forth to each other and work together on making cleaner electricity production by using hydrogen through the Carno to make that end electron to power something.
Turning to oil and gas. For the podcast, Thomas, I talked about electricity as far as energy, but I also talked about energy in terms of oil and gas. And I think this shakes both hands. You're based in Texas. You're based right outside of Austin. I actually used to live up kind of that way. You made an announcement where you will be testing Carno with unprocessed natural gas. Basically, the natural gas that's made out on site. It's usually the gas that gets flared, is it not?
Yeah. So for a little bit of background, like these oil and gas sites, they use a lot of electricity in the magnitude of like 20 to 30 megawatts in some instances per a site. And they usually don't have a grid interconnect, right? They're in pretty desolate areas. We can use a Carno generator to make electricity there. Now, one of the use cases that we saw, it's kind of a funny situation where you have an oil and gas site, it's producing natural gas, but that natural gas is dirty. It's got other gases in it that need to be scrubbed out before you could actually use it in a generator. So what some of these sites are doing is they're producing natural gas, they're shipping it out to go get processed and cleaned and purified, then most of it goes into a pipeline, but then they're actually taking some of that gas and trucking it back to the site in order to power those generators to keep producing more natural gas. We saw this as an opportunity where we can potentially just eliminate that whole transport of natural gas back to the site and just use what's coming out of the ground to be able to power the Carno. So as you mentioned, we announced a handful of months ago that we had taken some gas directly out of the Permian Basin, ran it through the Carno generator, and we were able to make the appropriate heat levels needed in order to run that genset. That's a pretty neat solution where it could have either been gas that would have ultimately ended up in a pipeline after it got cleaned up or trucked back to the site, or as you also alluded to, there's a lot of sites that are just flaring gas right now, and that's gas that we could potentially put right through the Carno and make electricity.
Yeah, that's great. That's one of the things that drives me crazy is the flaring of the gas, just because they don't have anything to do with it. right?
Yeah, it's like a big emissions problem, right? I mean, flaring is obviously better than just letting the methane go out into the atmosphere, but it's not a clean process versus we can put it through the Carno and actually give you a positive end product of electricity coming out.
How much electricity do you think you could possibly make from this kind of gas? To put it in perspective, do you think it would do the general site works? Because what they're doing is they're just bringing a diesel generator out, right? On sites where they're doing fracking, they have the pumpers, and I've talked with a guest called Evolution Well Services where they have electric frac pumping units. So how much energy do you think we could ultimately make at a site?
Yeah, so not trying to not answer the question, it is so dependent on the site. I mean, some sites have tons of excess gas that's coming out where we could power the entire site plus some, and then other sites just have very little excess gas and you wouldn't be able to. But I think there is, in most instances, a pretty good amount of gas coming out, and the target would be at the bare minimum power that site and then ideally even produce excess electricity.
Yeah, good luck on that one. That's great. Thomas, I wanted to talk about the pivot you made late last year. I hosted a panel that had a Hyliion guest right before you announced the pivot. And we were talking about EVs and the drivetrain technology for large trucks. And we announced that we weren't doing drivetrains anymore and we're just focused on the Carno. And just thinking back about this, do you think the customers just weren't ready for a large EV truck?
Yeah, obviously a major transition for the company and a tough decision to make. From my perspective, this is a company I founded 8 or 9 years ago with this vision of making electric semi-trucks, and we've effectively pivoted out of that space. But what we saw was when we took the company public back in 2020, there was so much momentum, so much excitement and interest in moving these semi-trucks to electric. And as time went on, the challenges that fleets were facing became bigger, the economy changed, the regulations that were coming into place were getting pushed out to the right. And ultimately, we just saw the adoption of EV trucking drastically slowing down. I think the exact same thing is being experienced in the passenger car space. I mean, that's why you're hearing a lot of the OEMs talk about they have excess electric inventory. And so that's where we saw that with the capital that we had remaining on our balance sheet, which we did this in a position of strength where we had about $300 million of cash on our balance sheet, it was better to stop consuming cash on the powertrain side and put that investment towards the Carno. And to give you some context there, we were burning about $150 million a year doing both the powertrain and the Carno generator versus we were able to reshape, restructure the organization and change the burn to about $50 million a year going towards the Carno. And that's going to be the focus of the organization for now as we go forward. You know, there may be opportunities to bring that technology back into that space, but for right now, the big focus is that stationary power application with this Carno generator.
Yeah, typical, which you see a lot in business, right? Just focus on the core tech and then you move out. But the idea of that truck would be pretty cool, right? You could use something like hydrogen or natural gas to electrically power the truck. It basically would be like the locomotive analogy, right? And you'd end up with a cleaner and more efficient solution than having a diesel-powered semi-truck, right?
Correct. Yeah, you effectively be making the locomotive of semi-trucks. And personally, I still strongly believe in that type of a solution. A lot of this is going to come down to our regulations going to force that move to electrification. And for fleets, they're in a position right now where they want to try a solution for a while and then determine if that's the end product they want to go forward with, and then they would buy it. If you're thinking about this from a startup company standpoint, the position we're in, we really need to go show our shareholders that we're driving volume adoption, we're getting units out there. And that was a little counter to what we were starting to hear from fleets, specifically as we saw this economy change and regulations push out to the right.
Around that time that you made the announcement to focus on Carno, you announced a strategic review of alternatives to powertrains. And I know that must have been a little bit nerve-wracking, but probably also might have given you a little bit of a second wind about, okay, what else can we do for these use cases, right? And so tell us a little bit about how that conversation went and what came out of it. And I hope it definitely did give you a second win, right?
Yeah, I think the company is on a great trajectory now. Obviously, very challenging times, especially for those who were unfortunately part of a reduction in force back when we made this transition, but put us in a position where we now have ample cash needed to go execute what we're trying to do. And now it's about just getting units out there in customers' hands. That strategic review, we looked at many different options of where we head with this, spoke to a lot of industry players about how we could potentially work with them or find a deal to do together. And, what we heard across the board was everyone was slowing down in electrification. The large, well-known players were starting to review themselves. Did they want to reduce their spend if they hadn't already started reducing their spend? And then many of the newer entrants in the space were in a position where they needed to go raise additional capital. And what they were hearing from the investor base was the appetite really wasn't there to invest into these early stage electric companies. And so put all that together. And that's why we said, okay, the best thing for us to do right now is take this technology, which was working, right? That's one of the other big things is we had semi-trucks running. We had them in fleets' hands. They were running really well. We were getting good feedback from fleets, but unfortunately, we just saw the best option was to pause the development on those, pull those vehicles back in, take them off the road, and reduce our spend and focus on the Carno. But hopefully you sense in today's call, there's a lot of opportunity with this Carno generator, a lot of interested parties. This is one of the things we recently just started speaking about, which is those 4 buckets of target market opportunities we're going after. We already have interested parties, whether they've already signed an LOI or we're in discussions with them about their potential adoption. Across all 4 of those buckets, we have parties interested in this solution, some great organizations to be working with as well. So this put the company in a position where we now have the cash we need to go execute, and we're still going after a extremely sizable market.
So the plan right now is get as many Carnos out there as possible, right? No plans right now to do maybe a larger version of the Carno. What does the next few years look like for Hyliion at this point?
So later this year is when we'll actually start deployments with customers. So that's going to be a huge milestone for us. And then as we go forward, we'll start scaling production of these units. But then we'll also look at doing some larger packaging of them, right? One of the things that's on our roadmap is looking at about a 2 megawatt unit, which would fit in the space of about a 20-foot shipping container. So as you think about these data center opportunities, the oil and gas opportunities where we're talking about, they need 10, 20, 30, 50 even megawatts of electricity. It's a lot easier to deploy a 2 megawatt container solution as compared to individual 200 kilowatt gensets. So that's on our roadmap to make that next step up in size. But one of the really unique things to point out is that those shafts that I mentioned earlier that actually produce the electricity, we're not actually changing those. We're just stacking more of them together to get that higher power output.
Very exciting. Well, good luck to you, Thomas. And also good luck to a fellow Texan here.
We'll have to get you down to Austin at some point and actually see the facility here. Really unique thing with the Carno is a lot of the components are made through additive manufacturing. What that means is we have this metal part that, as opposed to starting with a block of aluminum and cutting it back on a CNC, a miller lathe, we're actually making it with additive printing. So you go layer by layer producing this part. And what that does is it allowed us to really unlock the design of these components, these heat exchangers that we were making, to see much, much better efficiency. So that's one of the really cool things with the Carno is it uses additive manufacturing. And from a production facility standpoint, it allows us to scale pretty economically because as we want to increase volumes, we just buy more additive machines and start making more parts. This isn't a situation where you have to invest $500 million into a plant just to make genset number 1. So pretty economical way to go to market.
Yeah, I was curious about the additive manufacturing. You always see it for prototyping and be able to build something very quickly like that. But when you're doing scale, it still makes sense to do additive manufacturing.
So these components that we're making, you can't make them any other way. So we have to use additive manufacturing. But that's often a question we get is like, can this really scale into volume? And the answer is yes. If you think about where additive was 10 years ago, the answer would have been no. But today, machines have increased in throughput. The size of components that can be made are getting bigger, and the speed at which this is all printing is happening faster. So if you look at the industries like aerospace, healthcare, and even starting to go into automotive right now, they're actually using additive manufacturing in volume production. And that's what we plan on doing as well. So the nice thing is we don't need to go invent these machines. They already exist out there. These additive machines, we're just going to use them to make our really unique components.
Very nice. Well, I'm going to take you up on that, Thomas. I'm going to come up and see you from Houston next chance I get.
Yeah, please do.
Yeah, absolutely. All right, Thomas, I'm going to finish with a lightning round of your thoughts on different energy technologies, starting with natural gas.
I think it's a fuel that is here for a while.
Crude oil.
Hopefully reducing usage.
Nuclear.
Regulations are going to be the hurdle.
Coal with carbon capture.
Okay, coal with carbon capture, I think there are better energy sources out there.
Wind and solar.
I think we're starting to see we're at the limits of production capacity for wind and solar, at least here in the U.S.
Biofuels.
A great source to get to net zero emissions.
Hydroelectric.
Similar to wind and solar, we're probably tapped out. I'm even hearing that some of them are coming offline.
Geothermal.
Possibly a heat source for the Carnot generator at some time.
Yeah, I'd be into that. Energy storage.
Good short-term solution, but not the end-all be-all, solve everything that we need to do on the grid.
Energy efficiency.
To me, this is the unlock. Use the same amount of fuel we do and make more power.
And then finally, fusion power.
I'm not smart enough to comment.
All right. Thomas Hyliion, Hyliion, thank you so much for your time.
Thank you for having me on. I appreciate it.
That was Thomas Hyliion, founder and CEO of Hyliion, the manufacturer of the Carnot generator based in Cedar Park, Texas. I want to thank Thomas for his time as well as Bobby Cherian for setting this up. You can find plenty of pictures for this episode on energy-cast.com, as well as on Instagram at HostEnergy and X at HostEnergyCast. All the guests are sent the wrong completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stripp at Stripp Loops. That wraps up episode 183. Be sure to join us next week. We'll learn how one company is focusing on a new way to recycle lithium batteries. Until then, I'm Jay Downhauer. We'll see you next time.